Hello guys, welcome back. Today we again have some really good problems from the Allen score test series. So before starting the video, I would suggest all of you to pause the video before I start each question and obviously try, because the questions in today's and few upcoming videos will be really good, and I guess you should be able to do these questions if you are preparing for JEE Advanced. So here is the first question for today. I will wait a minute. Okay, I'm starting off. So basically we have an expression and we have a condition given that x plus y plus z is 1. So we have to find out the minimum value or the least value for this expression. So this is basically our 4x plus 2 divided by 2 minus x plus 4y plus 2 divided by 2 minus y plus 4z plus 2 divided by 2 minus z. Now what I will do is, because we actually can't find the least value for this expression because it basically contains both z in the numerator, z in the denominator, and same for x and y terms. Basically because we have least value of the expression, so what should click in your mind first, that we have to use am, gm, hm, either of them, that is two of them. So basically I will try to convert this into a form so that we can use it. So basically what I will do is, I am showing with one term and we will do the same with all the others. So let's take the first one, 4x plus 2 by 2 minus x. I will basically write this as 10 minus 8 plus 4x by 2 minus x. And we do the same for all others. You will soon understand why. So basically this will come out to be 10 divided by 2 minus x plus 10 divided by 2 minus y plus 10 divided by 2 minus z, all have 10s, and this comes out to be, I guess, minus 12. So now what I will do is, I will basically split this 12, I mean minus 12, as minus 15 plus 3. Basically I did minus 15 because I want to take this 10 out, so we have 5 to take common out, so this finally will become 3 plus 5 times. Basically I did the split and I am taking 5 as common, so this is 2 by 2 minus x plus 2 by 2 minus y plus 2 by 2 minus z minus 3. So now as you can see, now to find the minimum value for this expression is pretty easy. So basically we can use am greater than equal to hm, right? Now this will become 2 minus x plus 2 minus y plus 2 minus z divided by 3. Please note that I have actually, as I am doing with this expression, I am not considering 2 for now. I will multiply it later in the final result. Okay. So this becomes greater than equal to 3 divided by 1 by 2 minus x plus 1 by 2 minus y plus 1 by 2 minus z. Now we had an important result given here, that x plus y plus z is basically 1. So now we can write this thing as 6 minus of x minus whole minus of x plus y plus z. So this becomes 5, 6 minus 1, 5 divided by 3, which is greater than or equal to 3 divided by r 1 by 2 minus x plus 1 by 2 minus y plus 1 by 2 minus z. So now I take this here and cross multiply. So basically what we have is, I am not writing the ones for a reason, I will write soon, wait. This is 1 by 2 minus y plus 1 by 2 minus z greater than equal to, I guess this will become 9 by 5. Yeah. So now basically what we will do is, just a minute. So what I basically do is, we had ones here, I am not writing it, I will multiply this thing with 2 because that is what we have in our final result, right? So I multiplied both sides by 2. So this came out to be greater than equals to 18 by 5. Now our sum is done. We will directly put this and calculate the value. So least value for this expression will be 3 plus 5 whole multiplied by 18 by 5 minus 3. So this comes out to be, I guess, 3 plus 5 3s are 15. So 18 minus 5 is into 3 by 5. So this thing is 3 plus 3, which is 6. So your final answer is 6. I will tell you the option. So our correct option for this is C. This was not very difficult, but on very fundamental concept. So yeah, the question was good. Now we proceed to the next question. So here's our next question. I will wait for a minute. Okay, so now I am starting off. So basically we have something given of the form of x f of x. I will write it x into f of x equals to 3 times f of x whole square plus 2. And now we have to find the value for this particular integral. So we will basically deal with the integral later. What I am doing is first, because I guess we have to find something of f dash. So I will basically, just from a basic idea, I will try to differentiate this particular equation. So let's do that. So this comes out to be f of x plus x times f dash x, which becomes equal to 6 f of x into f dash x, basically. So yeah, now what I do is I send f dash x to this side and take common. So this becomes f dash x into 6 f of x minus x. So now basically we will have f dash x as f of x divided by 6 times f of x minus x. This is what f dash x came out to be. So now what was my actual basic idea behind doing this, I will explain. So what I will do is, this is what make the question difficult, because you can't actually have this observation like from normal. Okay, so I will take, say, some variable. I will let some variable, say u, to be equal to x squared minus f of x. So what you can say is, actually in all the terms we have x squared minus f of x. Now from that you could question me that why didn't you take 6 f of x minus x multiplied by x square minus f of x as the u as per your idea. So that is basically because not because we already have in f dash x this 6 f of x minus x. So basically when you differentiate this, when you find du, you will have f dash x which will already contain this. Okay, so this was the basic idea. That is why x square minus f of x was actually perfect in taking a substitution. I will show you guys after this. So basically this comes out to be du equal to 2x minus of f dash x dx. So now we put the value of f dash x from here. So du comes out to be 2x minus f of x divided by 6 times f of x minus x whole dx. So now I will change the page. So basically I will try to manipulate this a bit. If we multiply this and take the LCM, this will become 12 f of x. I forgot the x, I'm sorry, this is into x, minus 2x squared minus f of x, and this is whole divided by 6 times f of x minus x whole dx. So now I guess you guys can see, if we take a minus common out from this part, this is minus du equal to 2x squared minus 12x f of x plus f of x, this is plus, okay, I'm sorry, divided by 6 times f of x minus x, and this is whole dx. Now if we take a small look at the question, you guys will actually notice that the integral we had to find has actually come to us in the du part. Okay, you can see that integral and this part is exactly same, except that x square minus f of x is not present. So this was basically the idea. So now I'm not writing the integral anymore, because the whole part has come out to be minus du, so I will directly write minus du, and in the denominator we had x square minus f of x whole squared, I guess, so this will become u squared. Okay, I will check once anyways. So yeah, it's correct, we had u squared. So basically this comes out to be 1 by u plus c, and we have u as x square minus f of x, so this one becomes 1 divided by x squared minus f of x plus c. This will be your final answer to this question, and I guess I will check once. This is your option number A. So A is your correct answer. This was a very good question actually, because these small observations from the options and all will actually help to crack such type of questions. Okay, this was a very good question, and advanced can anyways ask you all this type. So now we proceed to the next part. So here's our next question, guys. And please note, this is option number C is 3 and option D is 4. They actually got missed out, so I have written it. So basically, alpha and beta are the roots of this quadratic equation x squared plus t square x minus 2t equal to 0. Okay, I will wait for a minute. Okay, I'm starting now. So this is basically x squared plus t square x minus 2t equal to 0. And now we have alpha and beta as roots, and as you can see from this long integral, there is alpha squared alpha beta, which is directly an indication of the fact that we have to manipulate many things using the relation of roots. So basically we have our sum of roots alpha plus beta, which is minus t squared, and product of roots alpha beta becomes equals to minus 2t. Yeah. So now I will directly move to the integral. This is integral I equal to minus 1 to 2. We have x plus 1 by alpha square into x plus 1 by beta square plus 1 by alpha beta dx. So basically we actually have, except alpha beta we know, but we have no knowledge that what kind of expressions in alpha beta will come from this part. So I will try to manipulate it first. So this becomes minus 1 to 2 and x squared plus this will become x times of 1 by alpha square plus 1 by beta square, and this becomes 1 by alpha squared beta squared plus 1 by alpha beta whole dx. So I guess now we have the resultant expressions that we have to find. This we have to find this, and this is pretty obvious anyways. So if we find out 1 by alpha squared plus 1 by beta squared, this is basically alpha squared plus beta squared by alpha square beta square. So I will write the numerator as alpha plus beta whole square minus 2 alpha beta. I hope this is pretty simple. And this is whole divided by alpha squared beta squared. So basically this is t power, I guess, 4 minus of 2 alpha beta, so it becomes plus 2t divided by alpha square beta square, which is 4t square. So this becomes 1t will get cancelled, so this is t cube plus 2 by 4t. I will move the page. Just a minute. Okay guys, there was a small mistake. This is 4, okay. 2 into 2 will make it 4. This is t cube plus 4 by 4t. So now this will become integral minus 1 to 2 x squared plus x into t cube plus 4 by 4t, and this is 1 by alpha square beta square, so basically 1 by 4t square, and this is plus 1 by alpha beta, so minus 1 by 2t whole dx. And now I guess we are in a good position to integrate this particular expression. So this becomes x cube by 3 from 2 to minus 1 plus t cube plus 4 by 40. I'm writing this in one go, okay. This is x squared by 2 and from 2 to minus 1 plus this thing I guess will become 1 by 4 t square minus 1 by 2t. And now we will have an x here limits 2 to minus 1 to 2, I'm sorry. So it will become 2 plus 1, which is 3. I wrote this directly. So now if we calculate this part, this will become 2 to the 4 to the 8 by 3 and minus minus plus 1 by 3 plus this is 2 to the 4 by 2, which is 2, and minus half, and this is t cube plus 4 by 40 plus 3 times 1 by 4 t squared minus 1 by 2t. Now I will manipulate this. So this basically comes out to be 9 by 3, which is only 3. 2 to the 4 minus 1 is 3 by 2, and this thing is I guess t cube plus 4 by 40. And in this particular part, what I will do is I will take the LCM. So this, I guess, comes out to be 2 minus 2t times 3 by 4t square. I understand. Like, I hope you guys understand how this is coming. So now we will take the LCM. I will do it for you guys. So this is our final result, and please note I have made a mistake here. This is 1, okay? This thing is 1 actually. So this is our result after taking the LCM and manipulating. So now I guess we will write out the final result. This is 3t cube, so 3t power 4, the highest coefficient, and this will be 24t square, and I guess this will become 3t plus, okay, this will become plus 12t and minus 12t, that they will get cancelled, and this is only plus 6 by 8t squared. This is our final result, and now I guess we have to find out the expression. So I will split 8t square among all the terms. This becomes 3t squared by 8 plus 6 by 8t square is 3 by 4t square. I am bringing these together, okay? And this is your plus 3. So basically we had to, I guess I will look at the question once. So our question basically said that we had to find out the minimum value of this integral. Now we have a particular expression in t plus a constant. So we have to find the minimum value for that expression and then add the constant to get our final result. So we will do that. So this is our expression. This is pretty simple stuff. We will directly apply am greater than equal to gm. So what we will basically have is 3t squared by 8 plus 3 by 4t squared by 2. This thing is greater than or equal to 3 by 8 t squared into 3 by 4 t square per half. So our t square and t square will get cancelled, and I guess nothing else is get cancelled. So this becomes 3t square by 8 plus 3 by 4t square, and this is greater than or equal to 2, and this is 3 square by 8 into 4, which is 4 square into 2 power half. So basically if we take this particular thing to be, say, some alpha, then alpha is greater than or equal to 2 by, this will come out to be root 2 from this 2, and 3 square by 4 square, so 3 by 4. So basically our alpha is coming to be greater than or equal to, this I guess will become 6 by, okay, 1, this will cancel. So this is 3 by 2 root 2, and because in the options, I mean in the question, we had a whole root under plus a constant. So our constant is here, this will be 3, and I'm taking the whole root under as root under 9 by 8, I guess, and this is plus 3. So this is our, I will not write this as I anymore, this is our I min. Now we have the result ready, so we will look at the question once. So our final minimum value was given to be root under p plus q. So p is basically 9 by 8 and q is 3. And now we have to find the value of box of p plus q. So let's do it. So p is 9 by 8, q is 3. So box of p plus q. Now 9 by 8 is 1 point, I guess it is 1.125, something like that. So this is 1 box value and this is 3. So our answer for this question will be 4, which is, I guess, option D. So this question is done. This was a very good question. Now I will proceed to the next question. So here is our next question. You can try it if you want. Please pause the video, and I guess this question is a bit long. So approximately 7 to 8 minutes will be, I guess, the time you will get for max to max. Okay. So you can take 10 minutes because it's preparatory stage. You can take 10 minutes to solve, or in the, because in the exam hall the standard time you will get for such a big question, if you actually correctly solve it, you will do it in about 7 to 8 minutes. You can take 10 minutes max to max, so please pause the video and try. So I am starting off. So basically we have a function f of x and we have to find out whether which of all of these options are true. So at first we have to check whether f of x is an onto function. So first I will write out f of x, which is basically 4x squared plus 12x plus 3 by 4x squared plus 4x plus 1. So this looks like a pretty bulky expression, so I will try to shorten it. And for that I will write out the denominator in the numerator. So this will basically become 4x squared plus 4x plus 1 plus, I guess, 8x plus 2. So now if we split this thing and the other small monomial we had, so basically this will come out to be 1 plus 8x plus 2 divided by 4x square plus 4x plus 1, or basically we can write this as 1 plus 8x plus 2, and this thing in the denominator pretty obvious, it is 2x plus 1 whole square. So this is our f of x. And now if we try to find out the domain of this function f of x, pretty obvious, domain of the function f of x will be f of x, I'm sorry, this is not f of x, this will basically be only x. X will map to all real numbers, and I guess because 2x plus 1 is in the denominator, so basically it won't map to only minus half, and it will map to all other real numbers. So this is our domain. Now we have to check the onto function, so we will, I guess, move on to find out the range. So to find the range of this function, there are many methods actually. I will go by the standard method that you guys usually adopt, which is 4x square plus 12x plus 3 divided by 4x square plus 4x plus 1. I have taken this to be a variable y, and so now as you guys know, we will multiply this, we will bring out a quadratic expression in x, and then we will put its discriminant to be greater than or equal to 0. So let's multiply. This will be 4x square y plus 4xy plus y equivalent to 4x square plus 12x plus 3. So basically, if we take all these terms to the LHS, we will have 4y, and from here minus 4x square plus 4y, I guess this will be minus 12x plus y minus 3, which is equivalent to 0. So now if we put the discriminant to be greater than equal to 0, this I guess will become, we take the y common out, so this is 16 times, I mean the 4 common out, so this is 16 times y minus 3 whole squared. Greater than or equal to, this will become, if we take again 4 from this, and this is 4ab, right? I'm sorry, b square is greater than equal to 4ac, so we have 4 from here and another 4, so 16, and this is y minus 1 and y minus 3. So pretty obvious, this and this will get cancelled. Now we move this to this side, and I mean the LHS, and take a y minus 3 common. So we will have y minus 3 minus of y minus 1 to be greater than or equal to 0. So y and y get cancelled, and I guess we will have a constant of minus 2. So we have to change the sign, and 2 doesn't matter. So basically we had minus 2, so 2 doesn't matter, and this will become y minus 3 less than equal to 0 because of minus sign. Okay, so this becomes y less than equal to 3. Basically we have the range of this function to be a minus infinity to 3. Now to check for an onto function, if we can use this expression also, because this and this are actually same. If we tend x to infinity, then I guess f of x, or what we have taken as y, it will tend to 1. And if we tend x to say minus half, because it's present here, then our f of x will basically tend to infinity. I'm sorry, this is minus infinity. So that's it. Now this has come to be 1 and minus infinity, and this is minus infinity to 3. So I guess option A is wrong. This is not an onto function. There are other ways also to actually find out the range for this function. I guess they are simpler. I should have done that, but This is the standard method that most of you adopt. So I did that. So now we will proceed to the next question. So basically our option A is wrong. I hope I said next question. Sorry, it's next option. So now we have in B and C, I guess they have, I will look at the question once and also show it to you guys. So our option B says that we have a set capital A, which is all those small a's such that this particular f of x equal to that small a has two solutions. And then the set capital A intersection with the set of natural numbers has at least three elements. And in the option C, we have a capital B such that it all will capital B equal to all those small b such that f of x equal to small b has got one particular solution for mod b greater than equal to 2. I mean, we have to prove this mod b greater than equal to 2. And for capital D, we have to find out whether fx is decreasing or increasing, and in this interval minus infinity to minus 1. So I guess rather than solving it individually, what we can do is we can actually try to draw the graph for this particular function. It is good because in LCD we are always taught how to draw graphs of complex functions, and it will be a good application in this question, I guess. So let's go to it. So what I will do now is we will first write f of x, which is equal to 4x squared plus 12x plus 3 divided by 4x squared plus 4x plus 1. Actually, I wanted to differentiate this. Okay, what we'll do is we'll actually use the first expression that we found, right? Because differentiating that is, I guess, easier than this. So this is 1 plus 8x plus 2 divided by 2x minus, I guess, 2x plus 1, I'm sorry, whole square. So differentiating this will be tedious, but I guess this will be simpler than this one. So let's go for this. F dash x. This will now basically become, if we differentiate this first part, this is 8 times 2x plus 1 whole squared minus 8x plus 2 multiplied by, there will be a 2 and 2x plus 1, and basically this 2 will come, and also if we differentiate 2x plus 1 there will be another 2, so this is 4 in total, divided by 2x plus 1 whole square was there, but now it is again squared, so power 4. So I guess we can take out 2x plus 1 common out from this entire thing. So this becomes 8 times 2x plus 1, and we have a 2 common from here, so minus 8 again times 4x plus 1, right? And this is our 2x plus 1 whole power 4, which gets 1 power subtracted. So if we try to manipulate this is 16x minus 32x and plus 8 minus 8. So I guess our, I will write it on the right side. This is f dash x. It comes out to be minus 16x by 2x plus 1 whole cube. This is our f dash x. Now if we try to ascertain certain things like the decreasing or increasing intervals of this, if we notice, say, because we have minus half, so I will try to go towards the right hand side. So basically what I am doing is, we have only one, I guess we have two critical points. One is minus half and the other is 0. I will try to draw the wavy. So basically we have minus on this side, so wavy will be like this. And I guess 2x plus 1 is whole cubed. So if it is an odd power, it will change the sign. Now please note this minus half is excluded, okay? I'm putting an empty circle. It will go like this. So basically if we try to find out the increasing and decreasing intervals, we can say f upward arrow means increasing. This will increase for x belonging to minus half to 0, and f will decrease for x belonging to minus infinity to minus half. I guess this is union with 0 to infinity. Basically these two parts, right? This and this. So yeah, now we have the increasing, decreasing intervals and everything else. So I guess we are in a good position to draw the graph, but I will also find out f double dash x to locate something about the maximas and minimas, and also to find out the nature of concavities of the curves at different points. So we will do that. So if we are, I will write f dash x for your reference once. F dash x was minus 16x divided by 2x plus 1 whole cube. Basically in the exam hall, I guess this part is sufficient to find your solution, but because I am drawing the graph, I am checking everything. Okay. So f double dash x, this will come out to be minus, what I am doing is I am, to make things easier, I am treating x as one function and minus 16 by 2x plus 1 whole cube as a separate function. Okay. So this becomes minus 16 by 2x plus 1 whole cube, and this thing is plus 48x. 48x basically because we are differentiating this, and we had a minus here, but because this will become 2x plus 1 whole power 4, so minus will become plus, and this is 2x plus 1 whole power 4. So in our LCM we have 2x plus 1 whole power 4, and this will become minus 16 times 2x plus 1 plus 48x. So 48 minus 32 is 16 times x, and because we also have minus 16, so I took it 16 times x minus 1 divided by our 2x plus 1 whole power 4, and this is our f double dash x. So basically some things which we can observe from here is that x equal to minus half, this particular vertical line will be a vertical asymptote for this curve. I guess you guys know what asymptote means. If you don't know, then you will get an idea from the graph. So now we will draw the graph of this particular function. This is, say, the baseline, and this is, I'm taking another line. So basically if this is our x equal to minus half on the left hand side. Just a minute. This is x equal to minus half. So if you observe the concavities, I guess because f was increasing in minus infinity to 0. Okay, what we will do is we will also try to find where this graph will be intersecting on the y-axis. Just a minute. I'm doing that. So I'm taking help from this. Basically, to find out where it intersects on the y-axis, we put x as 0. Okay, we have to find f of 0. So this is 8 into 0, 0, 2, and 2 into 0 is again 0. So 1 plus 2 by 1 is 1 plus 2. So basically it will intersect at 0, comma 3. Now I will return to the graph. So in between minus half to 0, okay, this is, I will show you the intervals also. Between minus half to 0, now both are open. So basically that is why minus half is a vertical asymptote, because this graph will reach very, very close to minus half, but will never exactly intersect minus half even at infinity. So this will be, I guess, something like this. From minus half to 0, the graph's nature will be something like this. Basically it's actually, although I have shown the arrow in this part, it's actually signifying that from minus half till 0 you are actually going up. Okay, I have shown this arrow in this direction to denote that it is going towards minus infinity. But basically if you cross minus half, like this is minus 0.5, if you come from minus 0.5152, basically you are actually increasing like this. So this is to be noted. And we have also the decreasing intervals. So basically as we go to the left hand side of minus half, the graph will become like this. This and this are never intersecting this vertical asymptote. Okay, please note. And now it is also decreasing from 0 to infinity. This point is 0, comma 3. It's, I guess, decreasing from 0 to infinity as well. So something like that. And please note one more thing. This is your y equals to 1. Okay, this thing, this is 0, comma 1. So basically y equals to 1 for this particular part of the curve, you can say y equals to 1 is maybe a horizontal asymptote. I will extend this also if you guys want, like this. So basically this will also never intersect y equals to 1, okay. That is what asymptotes actually mean. Asymptotes are those horizontal or vertical lines on, like if there is an asymptote to a particular curve, it means that that curve will trace the asymptote, it will go maybe very close to it at infinity or minus infinity, but it will never exactly intersect that asymptote, okay. And that happens because if you see, whether you see f dash x or f of x, everywhere in minus half this function will always become its like single differential, double differential, everything will become undefined. So this will never intersect. So this is our graph for the question. I guess now we are ready to check the options. So basically in our option C, we have to find out one small a such that for that small a, like it is y equal to small a, such that this curve with y equal to small a has two solutions. So if you observe carefully, we will not include y equal to 1 basically in our intervals. So in minus infinity to 1, here in any region you draw any horizontal line, it will obviously intersect the curve at 2 points. So if we try to find the intervals for small a, basically first we will have minus infinity to 1, and after that if we try to find out above 1, here also in between 1 to 3, above 3 there will be no solutions at all, but in between 1 to 3, please note 1 to 3 will be both open. In between 1 to 3 also there will be always two solutions, whichever horizontal line you like draw. So yeah, this is our required interval for small a. So this is for two solutions, okay. So I guess capital A will contain all these elements. So now if we try to take a intersection with the natural numbers, I guess minus infinity, so all the negative numbers are already debarred and 0 will not be there, so we will have only 1 to 3. This part won't be there, okay, because natural numbers start from 1 and this is open 1, so basically it will end at some 0.91 trillion 1 million nines. So this is our required. So basically if you try to find out, this will only have small a equals to 2. Okay, I mean the result of this intersection will be only one natural number, right? Because 1 and 3 are both not included. So in C we only have one element, and it was written I guess in option C that we will have two elements. So basically C will have one element, so option C is wrong. So we will check the final option now. Obviously it will be correct because A, B, C are all wrong, but still we will check. So now for our option D, if we look at the question, we have one solution, right? We have to find out at which places it will have only one solution. So here basically small b will be exactly y equal to 1 and y equal to 3. If you observe the graph, at y equal to 1 it traces only one point, because I will show you the graph once to explain better. If you observe carefully, y equals to 1 has, this part is asymptote, this part is also asymptote. So basically y equals to 1 intersects this curve, exactly y equals to 1 intersect this curve only once. Same for y equals to 3, right? So b will be exactly within curly braces, it will have two elements 1 and 3, so mod b will be 2. The set was capital B, so mod b is 2. So yeah, our option D is correct, and this question is done. We have only option D as the correct answer, which is very ironic because I guess this question was in the multi correct type. Okay, no, sorry, it was only in single correct. Anyways, you have to check out all the options, and it was a very good question, okay. This question was very good. It tests all your graph drawing abilities. How do you know about the points, asymptotes, and everything? So, if you guys actually went to solving this from taking intervals and finding out these, although I found out these, but if you find out till f double dash x, that was also fine. So, basically, graphical approach is, I guess, the most fundamental form in which you can do this question. So, yeah, now we will proceed to the final question. So here is our next question. This is also a very good question. This is like those brainstorming type questions you can get for JEE maths maybe. So I will wait for a few seconds. Okay, I'm starting off. So basically we have our A1 as 1, and we have a sequence given as an equals to an minus 1 plus 1 divided by your an minus 1. So I guess we don't get anything from this. Even if we evaluate, I don't think we will get anything fruitful. So what I will do is I will try squaring this particular expression. Maybe squaring will help, because we need a like something greater than or less than. You know what I mean? Okay, I will show you guys. Let's square this up. This will be an square equals to an minus 1 square plus 1 by an minus 1 square, and this is plus 2. So basically we have an square minus an minus 1 square, this is equal to 2 plus 1 by an minus 1 square. So now 1 by the square of a particular number can never be negative. So basically this whole quantity, this part is positive. So 2 plus some positive quantity will be greater than 2. So basically the take we have from here is an square minus an minus 1 square will be greater than 2. Right. So what I will do is I will try to take sigma on both sides. Basically I'm trying to sum it up, sigma from n equals to small 2, because we already know a1, right? And this is your capital N. From this is an square minus an minus 1 square, and this is, I guess, greater than sigma small n equal to capital N2. So if we add up all the expressions, I guess this will be a capital N square minus a1 square. All the terms are getting cancelled. It's like minus plus, and the common terms will get cancelled, right? I hope you can understand. So this becomes greater than your 2 times capital N minus 1, because 1 is not there and the sum will be capital N, obviously. So we have a1, we know it is 1. So I will send this thing to the RHS. So basically our an square will be 2n minus 2 plus 1, which is 2n minus 1. So an is basically greater than 2n minus 1. Yeah, I guess now we are in a position to ascertain the value of this sine inverse thing. Let's do that. So we had a sine inverse, I guess, a75. So if we put n equals to 75, this will come out to be greater than 75 to the 150 minus 1 root 149. Now getting only one part greater than is not sufficient to make a comparison and find out the correct options. So what I will do is I will basically move to sine inverse, and within sine inverse we actually had this a 75 minus 12, right? Box function doesn't matter, we will bring it later on. So what I will do is, to find out the other part, I will try to define this. So as you know, for sine inverse to be defined, this thing has to lie in between minus 1 to 1. So here is it. Now if we take 12 to both sides, this will become 11 less than equals to a 75 less than equals to 13. So I guess from here, and we also have a 75 which is greater than 149. I will try to find the approximate value of 149, just a minute. So basically what we can do is 144 and 169 are two perfect squares, right? And 149 lies in between them. So basically this value will rise somewhere in between 12 to 13. It's 12 point something. So a75 is greater than 12. So here is 11, here is 12, here is 13. So this is 11 to 13, and this thing is greater than 12. So basically a75 will lie somewhere in between 12 to 13. Yeah. So because it's lying between 12 to 13, obviously this part will come out to be positive, right? A75 minus 12. From here we can conclude easily that, and 12 it will never be 0 also, because 12 is not included. It will always be something that is greater than 0. Now a very clever take from this part will be because a75 minus 12 is basically greater than 0, and we know sine inverse x, it has a range of minus pi by 2 to pi by 2. Now we never would actually need minus pi by 2, because if a75 minus 12 is greater than 0, its sine inverse will be also greater than 0. So it will be a minute quantity, but its box value, I mean the greatest integer function, will either be 0 or 1. It will like, it can be 0, 1, 2, 3, anything, the greatest integer function, right? Like positive values, but we will never have negative values for the box function of this thing. So basically if we find out if I take this to be say alpha, so box of alpha will be always greater than 0. It will never be negative. So I guess now we are in a position to eliminate the options. We will look at the options once. So we were basically asked, because this is multiple type, so we were basically asked that sine inverse this box function can't be equal to. So easily our options are A, B, D. These are correct options because all of these are negative, and within box function if we have a positive number, then the box of it can never be actually negative, right? And it's also not equal to 0. It is always greater than 0. I also showed you how. And say if they had asked us that this can be equal to, then it can be equal to say C, because it's the only positive number present. So for this question our correct options will be A, B, D. This was a very nice question, like brainstorming type. You actually had to like not find out the correct answers, but that point where we reached, where we actually realized that the box, inside the box there will only be a positive number, that was the most important part. So I guess this will be the final question for today, guys. I hope you enjoyed this session. I will bring out such questions also in my further videos. So please like, share and subscribe. And thanks for watching. And also if you have any confusions or you have any recommendations that I should bring up this or that, please write it down in the comments. Thank you all.